Welcome to the Explainer. Today, we're taking a journey from reading chaotic, unstructured log lines to building clean, real-time metrics. We'll be looking specifically at Grafana Loki and its query language, LogQL. Now, if you're an IT support engineer, an SRE, or honestly anyone who has ever stared blankly at a wall of text trying to figure out why a system is broken, this explainer is exactly for you. Let's dive right in.
Picture this scenario. Your pager goes off at 2 a.m. You log in, open your monitoring tools, and you're instantly hit with a wall of red text. Literally 1 million log lines are just flying across your screen. So how do you actually spot the root cause and all that? Trying to read raw log lines in a browser at that speed is just going to crash your brain. You can't manually process that kind of volume. You need a way to actually understand the scale and the trend of what's happening, rather than just staring at individual text strings.
And this brings us to the core solution. In LogQL, you basically have two fundamental types of queries. On the one hand, we have log queries. These just return the raw contents of the log lines, strings of text or maybe some JSON. But on the other hand, we have metric queries. These actually extend log queries by applying a mathematical function to the results. Since Grafana Loki stores logs in their raw form and only indexes the metadata labels, it doesn't actually store pre-aggregated metrics for you. Instead, metric queries are your secret weapon for extracting numbers and seeing the actual trend right at query time. They literally transform your text into time series data.
Triaging a payment outage, the scenario. All right, let's say a high-stakes alert just fired for a payment gateway outage. Customers are getting errors at checkout, and it's on us. We're opening up the dark theme of Grafana Explorer, and we need to find out exactly why this is happening and just how bad it really is.
As a support engineer, your muscle memory probably has you typing this base query straight into the editor. It's a super basic log query. It starts with your log stream selector inside those curly braces, targeting the label job equals payment. Then, it's followed by a simple line filter, pipe equals error. This just tells Loki, hey, return every single log line from the payment job that contains the word error.
So you hit run and boom, you've got your raw error lines. But wait, how many of these are actually happening right now? A giant wall of filtered red text still doesn't tell us the true scale of the failure. Is this 10 errors? Is it 10,000? Are they actively spiking? Or is this just standard background noise? To answer that, we absolutely have to transition from a log query to a metric query.
The crucial trick here is knowing exactly which function to use. Let's introduce count_overtime. This is a log range aggregation function, and what it does is incredibly powerful but surprisingly simple. It just counts the log entries for each stream within a given time window. It essentially groups all that chaotic data into manageable blocks of time. So instead of 1,000 individual log lines, you get a single, clean number representing those lines.
Let's actually apply it. We take our original log query, wrap it up in parentheses, and add that count_overtime function. Notice that 1m in brackets at the very end? That's our time duration, or our interval. We're telling Loki, take those payment logs, filter for the word error, and count exactly how many of those lines pop up in every single 1-minute window.
When you hit run on that updated query, the visual payoff is immediate. Your raw table of text instantly transforms into a time series graph. And right there, we can see the exact minute the payment outage spiked. We go from a totally normal baseline of maybe 2 errors a minute, straight up to 450. Suddenly, we have a crystal clear visualization of the incident's impact.
But let's push this just a bit further. We have the count per minute, but how do we normalize this per second? And why does that even matter? Well, per minute counts can feel pretty clunky when you're dealing with really fast-moving service level indicators, or SLIs. In the site reliability engineering world, measuring things per second is pretty much the standard for tracking exactly how fast you're burning through your error budget.
To get that slick per-second view, we just zoom back into our query editor and swap out count_overtime for the rate function. We keep that exact same 1-minute window at the end, but while count_overtime gives you the raw total in that window, rate does the math to calculate the per-second average over that same interval.
And here's the output, 7.5, meaning we're seeing exactly 7.5 errors every single second. This one clear number completely cuts through the noise. It helps your operations team immediately grasp the velocity of the failure. Think about it. If your service level objective says you can only tolerate 1 error per second, seeing 7.5 instantly tells you that you are aggressively burning your error budget and you need to escalate right now.
Let's level up this query one last time.
We know the overall payment job is throwing 7.5 errors a second, but modern architectures are made of dozens of microservices, right? So which one is actually breaking? By slapping sum by service to the very front of our query, we're performing a vector aggregation. We're basically telling Grafana to take that per second rate and group the math by the service label. This instantly draws separate lines on our graph, perfectly isolating the broken microservice, say the credit card processor, from all the healthy ones. Pinning the solution to your dashboard. We've just done some seriously incredible ad hoc investigation in Grafana Explorer. But the real superpower of LogQL metric queries is turning them into permanent observability fixtures. You definitely don't want to be typing all this out every single time an alert fires. If you want to practice this yourself, and you totally should, open up Grafana Play at play.grafana.org. It's a fantastic demo environment. You can build your LogQL metric query in the Explore tab exactly like we just did. Then, right up at the top, just click the Add to Dashboard button. You can save this brand new time series metric right alongside your infrastructure, CPU, and memory charts. And just like that, the entire IT support team can monitor the specific error rate continuously.
To wrap up our journey today, let's quickly summarize the core technical takeaways. We learned that while log queries give you raw text, metric queries give you actual trends. We used count underscore over time to understand our raw log volume within a specific interval. Then we swapped to the rate function to normalize that volume into a fast per-second speed. And finally, we grouped our results using SumBy to instantly pinpoint the failing component. We went from a chaotic, panic-inducing wall of text to a clean, highly actionable observability metric.
Which really leaves us with this final thought. What hidden trends are buried in your raw logs right now, just waiting to be turned into a metric? The data's already there, sitting in your log streams. I highly encourage you to open up Grafana, stop relying entirely on those manual keyword searches, and start building your own LogQL aggregations. Thank you so much for joining me on this explainer, and happy querying.